Okay, students, I'm guessing the next question that you're going to get stuck on in your homework is number 35. 35 is an awesome geometry question. So get ready to combine what you know about circles with what you know about quadrilaterals, chapter 6, and what you know about right triangles, chapter 8. It's all in this problem. Okay, let's start with what do we know about circles from this section, particularly about tangents that we could apply. We do have a tangent line, and that would be PQ here. And we had two theorems. One had to do with when we had two tangents. We just have one tangent. It would be a common external tangent for our two circles, circle R and circle S. And so I'm going to look to apply the first theorem that we talked about, a tangent and a radius, because I do have two radii, one for each circle. Tangent and radius always make, and hopefully you're saying, a 90-degree angle, which means that I'm going to have a right angle there and a right angle here. Okay, now let's think about what that means. I've got two lines that are perpendicular to the same line. Both of my radii are perpendicular to the length of PQ, which, by the way, that's what we're trying to find. Okay, we're even going to go back to chapter 3 right now. Two lines perpendicular to the same line. What can I say about my two radii, PR and QS? And if you're thinking that, you are right on. We do have parallel lines there. So I now am looking at a quadrilateral, PQRS, or PQSR, I guess if I say it in order, with one set of lines that are parallel, one set that are clearly not parallel, and therefore I'm going to identify PQSR as a trapezoid. You got it. So I'm looking at a trapezoid, and I'm going to try to figure out essentially the height of the trapezoid. But I don't know much about solving trapezoids, I really don't. So I'm going to split my trapezoid into two shapes. And I really like, you know that I really like right triangles. So I'm going to actually split it into a right triangle and a rectangle, is my thought. Just so I get some more numbers on the page. So I'm going to create a rectangle here by drawing from S straight down, if you want to think of it that way. And make two more right angles here. So there's the rectangle that I just created. Now, how's that help me? Well, I know the length of QS is 4. If I actually created a rectangle, I know that opposite sides are congruent. So I now have a 4 over here. That whole length, of course, was 6, which leaves me with how much for this part right here? And that's going to be a length of 2. So I now have a length of 2. This would be the hypotenuse of a right triangle that I just created. And this other leg is going to be X, because that's opposite side to the other side in my rectangle over here, which is X. So I'm now focusing on this blue right triangle on the side of my trapezoid. And the question is, what do I know about the hypotenuse of that triangle? Because right now I know nothing, but I can't solve for X. I'm hoping that I can use this right triangle to help me out. And of course I know that a squared plus b squared is equal to c squared, and I would love to be able to use my Pythagorean theorem. But I need to know two of my sides, and right now I only know one of them. So I'm going to stop there, and you are going to look at segment RS, and you're going to think about everything you know about circles, because there is one magic trick about circles that will get you through a lot of questions. It has to do with radii. What do you know about radii of a circle? See if you can figure out the length of RS. If you can get a number for the length of RS, then you can go ahead and do your Pythagorean theorem to solve for X, and you've got this problem. Good luck.